All right.
Yeah. Hi everyone, it's Simon and Stephen again, and we're here to give you feedback on the third and final week of the MOOC on functional programming in Erlang. So, first of all, well done for getting where you got to.
Congratulations. Yeah.
And thanks for all the comments and all the contributions that you've been making. I've been taking a look at them, but Stephen in particular has been going through them and has been. I think we've both felt very pleased with them.
Yeah. No. Really great interactions. No one got too terribly angry at someone else, which is a nice place to have on the internet, I think.
Yeah.
And yeah, a lot of really fun discussions to read. I really enjoyed that. So
good. So something that came out, the thing we thought we'd talk about today, there was some discussion about whether the examples were too mathematical, in inverted commas. Yeah. And I'm not. This is not simply a defence of. I'm not feeling defensive about it, but I just wanted to say a tiny bit about why we've chosen mathematical examples. One reason is simply brevity. If you want to fit an example onto a slide, you want to see the essence of what's going on when you filter a list. Numbers are nice because they've got enough structure that you can perform operations on them, like addition and so on. You can perform simple tests on them. Is it less than 0 and so on. So writing things which will be inside a map or a filter function comes very naturally on lists of numbers. So that's one good reason for doing it. But I think we did try in some places to do things that were perhaps a bit more like standard OO examples. In particular, the shapes where we had either circles or rectangles. We did some examples which was a mapping, taking the area of every shape in a list and filtering out the circles from a list. We were doing those sorts of traditional list operations over things which were emphatically not, well, they are mathematical in a sense, but they're more like traditional programming examples. And what you see there, they are just a bit more wordy. There's a lot more syntactic noise in there than there is in an example with numbers. So there is a downside to that. I don't know. Had you any thoughts about this?
I mean, I think if you were looking for, I guess, an extra challenge, going back through weeks 2 and 3 especially, and trying to kind of rewrite shapely versions of a lot of those exercises, as opposed to kind of the more numbery ones. If you took the shapes thing and tried to come up with equivalents that map over lists of shapes or filtering lists of shapes to see how that would work, or any object that kind of you use in your day-to-day programming, I guess, would be a worthwhile pursuit if you were, I guess, a bit frustrated with the abstractness of what we've been doing so far.
And I think the other thing, and you could say this is mathematical again, we wanted to do some language processing, because what you're doing in processing a language is taking, for example, text and extracting structure from that, or taking structure and turning it back into text, or transforming that structure in some way. Now, the example we chose was, okay, arithmetic, so you could say that's mathematical, but think of a DSL in your application area and put that into Erlang. Parse strings into DSL expressions, simplify DSL expressions, and so on. For example, do some hardware layout. If you want to do something in the electronics area, do something to do with order processing. Common to a lot of these things is extracting structure, getting rid of pretty printing to structure, evaluating things in some way, processing them, so the expressions example, which you find in the masterclass videos, covers all those things. And I think again that's meant as a sort of capstone. It's not a required part of the course, but if you want to see how you apply the ideas that we've been talking about on a slightly larger scale, that's a place to look. So I hope that gives you a response. We appreciate that the examples were toy examples in many cases to illustrate the key idea. If you get the key idea with those, you'll be able to apply it yourself to a domain of your choice. The other thing to say, of course, there was some discussion about what you thought about Erlang. And one or two people said, well, Erlang's got concurrency. Why didn't you talk about that? And the answer is, there's a MOOC starting on April the 3rd, which is a follow-up to this. We could have built a 6-week MOOC on programming in Erlang. What we decided to do was split it into 2 halves. So it means for people who are still on the course, there's time to catch up, time to consolidate before the next one starts. So there's a 3-week gap, and then you can get started with concurrent programming in Erlang. The course is already open on FutureLearn, so you can sign up for that, and we'd encourage you to do that. And what we'll cover there is, in the 3 weeks of the course, the first week is the basics of concurrency in Erlang. So separate processes which communicate only by message passing between them, and see how that works. Second week we'll talk about fault tolerance. Erlang is well known for its strong, robust approach to building fault tolerant systems. That's what we'll talk about in the second week. The final week we'll talk about how these things begin to scale up. So looking at OTP, the Open Telecom Platform, the library of generic behaviours that Erlang has. So we'll be talking about that in the final week. So that will show you the reason, one of the reasons why people go for Erlang is those sorts of facilities, so that you can build a server, for example, very easily, straight out of the box with those generic components. So we look forward to you joining that course and look forward to talking to you then.
Yep.
So
see you in a few weeks.
Yeah, goodbye, and thanks very much for taking part in the course. Thanks. Bye-bye.
Bye.